We're going to be teaching how to solve and graph polynomial functions. So we're going to use the function p of x, which is written here. So to start off, what you have to do is you have to factor the function. So starting with the numerator, we have a degree of 3, so we're going to use synthetic division. So what you do is you write out the coefficients of the numbers. So we have 1, -8, 5, and 50. And then you test a number. So we're going to test 5 because that's a nice and reasonable number. And what you do is you drop down the first number and then you multiply it by the 5 or whatever number you chose. And then you add it to the second number and you keep going in that pattern. And then as you can see, we got 0 with the last number, which is good, which means that 5 is a factor of this function. So one of the factors in the numerator is going to be x minus 5, and we're going to be left with what was written on the bottom was the 1, -3, -10, which means that x minus 5 times x squared minus 3x minus 10 is equal to the numerator. And when you factor x squared minus 3x minus 10, you get x minus 5 times x plus 2. And when you factor the denominator, that's a really easy factor also, x minus 5 times x minus 2. And as you can see, the numerator and denominator have x minus 5 in common, so we're going to cross those out and there's going to be a hole there, which means that wherever x equals 5 is on the graph, there's not actually a point there. So to find that, we're going to just plug 5 back in, and when in the numerator you do 5 minus 5 and get 0, that's just going to make the whole thing equal 0. So the whole is going to be at 5, 0. We're having some technical difficulties. And now we're going to move on to the next slide where we're going to talk about the important things that you need to find to graph this function. So this is slide number 2. Our function is written up at top, and so the first thing we're going to look for is the vertical asymptote. So to find that, we're going to set the denominator equal to 0 and find that the vertical asymptote, VA, is where x is equal to 2. And then the next thing we're going to find is if there's a horizontal asymptote or a slant asymptote. And to find that, we look at the degree of the numerator and the denominator. So if you look at the numerator, we can see that there are 2 x's, so the degree of that is 2, and in the denominator there's only 1 x, so that degree of that is 1. That means that there's going to be a slant asymptote and not a horizontal asymptote. So to find the slant asymptote, we're going to do long division of the numerator by the denominator. So the numerator, when multiplied out, is x squared minus 3x minus 10. And we're going to divide that by x minus 2. So when you do long division, you take the first factor in the denominator, which is the x, and you're going to use that to divide. And so we're running out of space here, but you can probably here. Minus 1. And so there is a remainder on this function, but the remainder when you're doing slant asymptotes is going to be such a small and insignificant factor that we're just going to pretend it doesn't exist. So our slant asymptote, SA, is going to be equal to y equals x minus 1. And then the other things we need to find are the x-intercepts and y-intercepts. X-intercepts plural and y-intercepts single. So x-intercepts is found by setting the numerator to 0 and solving. That'll give us at -2, 0 an x-intercept. And we would also have one at 5, 0, but as you remember, we have a hole there. So instead of having a point, we're just going to have a nice little hole. And the y-intercept, to find that, we're just going to plug 0 in to the function, and we're going to get -5 times 2 over -2. And when you cancel out lots of things, you get an intercept at 5, 0. I mean, yeah, 0, 5. I said that backwards. Sorry. We meant 0, 5. Now we're going to graph our function.
Okay. So to graph the function, we have to first state the asymptote, and the vertical asymptote is at x equals to 2, so it's over here, and the horizontal asymptote is
Slant
asymptote, is at x equals to no
Y
equals to x minus 1. So we are going to graph that, and there will be a hole over x equals to 5, which is over here, 5, 0. And if we plot in more points, for example, the intercept, which will be at 5, 0, it will be here, and there will be another point at the x-intercept, the y-intercept will be at -2, 0, which will be here. And so after we graph it, it should look like something like this. And to graph the other side of the asymptote, we plot in points which will be 2, -3, which will be a point over here. 4, and there will be another graph over here.
Yay!
Okay.